Hello everyone. Today we are going to analyze this frame using stiffness matrix method. Before analyzing, let us see the frame one time. In this frame, there are two columns, column AB and column CD. Also, there is a beam BC. In the column AB, there is a point load 16 kN acting at a distance of 1 meter from the point B. In the beam BC, there is uniformly distributed load 6 kN per meter. This load is acting for the full span. In the column CD, there is a point load 20 kN. This load is acting in the center. In the point C, there is a nodal point load 8 kN. Height of the column AB is 4 meter. Height of the column CD is 6 meter. Length of the beam BC is 5 meter. The moment of inertia for the column AB is 2I. For the beam BC is 1.5I. For the column CD is 3I. In the points A and D, there are fixed supports. This frame is a sway type frame because the columns AB and CD are having different heights. Let us assume that the sway occurs towards the left side because the column AB is shorter than the column CD. Now let us find the fixed end moments. First, let us find them in the column AB. In the column AB, there is an eccentric point load 16 kN. The formulas to find the fixed end moments are minus WAB square upon L square and positive WA square B upon L square. Let us apply the values inside the formulas. W is 16, A is 3, B is 1. After applying, we are getting M of AB and M of BA. Now let us make the fixed end moments in the beam BC. In the beam BC, there is UDL 6 kN per meter acting for the full span. The formulas for the fixed end moments are minus WL square upon 12 and positive WL square upon 12. In the formulas, let us apply the values. W is 6, L is 5. When we apply them, we are getting M of BC and M of CB. Now let us find the fixed end moments in the column CD. In the column CD, there is a point load 20 kN. It is acting in the center. The formulas to find the fixed end moments are minus WL upon 8 and positive WL upon 8. In the formula, let us apply the values. W is 20, L is 6. When we apply them, we are getting M of CD and M of DC. Since this frame is subjected to sway, we have to find the horizontal reactions in the points B and C using the loads and the fixed end moments. First, let us take the column AB and find the horizontal reaction in the point B. To find HB, I am going to take moment about A. In this case, I am moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. HB is acting in the anti-clockwise direction, so it will be positive and the distance is 4 meter. So for HB, the point load is acting in the clockwise direction, so it will be negative and the distance is 3 meter. The fixed end moment in the point A is acting in the anti-clockwise direction, so it will be positive. The fixed end movement in the point B is acting in the clockwise direction, so it will be negative. Finally, for HB, we are getting 13.5 kilonewton, which is acting towards the left side. Now, let us find HC. In the column CD, we have the symmetrical loading. In the center, there is a point load, so we can easily find HC. When we divide this 20 by 2, we will get HC, which is acting towards the right side. Now, let us find the kinematic indeterminacy of the frame. In the joint B, we have the slope theta B. In the joint C, we have the slope theta C. Also, there is sway. So, the kinematic indeterminacy of the frame is 3. They are theta B, theta C, and delta. Now, let us make the fully restrained structure. For that, we have to provide fixed supports in the points B and C. Now, let us make the coordinates diagram. In this analysis, there are 3 coordinates. In the point B, we have the slope. So, let us make the first coordinate in the point B. In the point C also, we have slope. So, let us make the second coordinate in the point C. The third coordinate is the sway. Since the sway occurs towards the left side, let us keep the coordinate also towards the left side. Let us see the formula to find the displacements. Delta matrix is equal to K matrix inverse into P matrix minus PL matrix. Inside the delta matrix, we will have theta B, theta C, and the sway delta. In this formula, now let us find the P matrix. Let us see how to find the P matrix. Our first coordinate is in the point B and the second coordinate is in the point C. To find P1 and P2, we have to check whether in the points B and C there are any movements. In the points B and C there are no movements. So P1 and P2 will be 0. Our third coordinate is the sway. To find P3, we have to check the points B and C if there are any horizontal loads. In the point B, there is no load, but in the point C, we have a load 8 kilonewton. This load is acting towards the left side. Our coordinate is also acting towards the left side. Since this load is acting in the coordinate direction, it will be positive. In this formula, now let us find the PL matrix. Our first coordinate is in the point B. In the point B, we have found two fixed end moments, M of BA and M of BC. To find P1L, we have to add these two moments. After adding, we are getting minus 3.5. Our second coordinate is in the point C. In the point C, we have calculated two fixed end moments, M of CB and M of CD. To find P2L, we have to add both of them. After adding, we are getting minus 2.5. The third coordinate is the sway, which is acting towards the left side. To find P3L, we have to add the horizontal reactions in the points B and C. We just saw that our coordinate is acting towards the left side. Since this reaction is acting in the coordinate direction, it will be positive. This reaction is acting in the opposite direction of the coordinate. It will be negative. When we add these two values, we will get 3.5. In this formula, we have found P matrix and PL matrix. Now we are going to find the stiffness matrix. In the stiffness matrix, first we are going to find these four values. For that, we have to apply unit displacement in the first two coordinates. Then we can use the formulas. If the fair end is fixed, the formula is 4EI upon L. If the fair end is hinged, the formula is 2EI upon L. We have to apply the unit displacement in the fully restrained structure. Now let us apply unit displacement in the first coordinate and find k11 and k12. Our first coordinate is in the point B. So in the point B, we have to apply unit displacement. I have applied unit displacement in the point B. Previously in the point B, there was a fixed support. But when we apply unit displacement, we can assume that it becomes a hinged support because in the fixed support there will be no displacement. Let us see how to draw these curves. We are applying unit displacement in the point B. So from the point B, we have to make two clockwise curves. One curve towards the point A and another curve towards the point C. Then we have to see the direction of the arrows and draw these curves. Now let us find K11. For that, from the point B, we have to look other ends. In the end A, there is a fixed support. If the fair end is fixed, the formula for the stiffness is 4EI upon L. Length of AB is 4. Let us apply that. The moment of inertia for AB is 2I. So instead of I, we have to apply 2I. Now let us look other end C. In the point C also there is a fixed support. So we have to apply the same formula 4EI upon L. Length of BC is 5. Let us apply that. The moment of inertia for BC is 1.5I. So instead of I, we have to apply 1.5I. For K11, we have to add these two values. After adding, we are getting 3.2EI. Now let us find K12. For that, from the point C, we have to look other ends. First, let us look the end D. In the point D, there is a fixed support, but for the column CD, there is no slope curve. If there is no curve, there will be no stiffness. Let us look other end B. In the point B, there is a hinged support. If the fair end is hinged, the formula for the stiffness is 2EI upon L. Length of CB is 5. Let us apply that. The moment of inertia for CB is 1.5I. So instead of I, we have to apply 1.5I. Finally, for K12, we are getting 0.6EI. Now, in the stiffness matrix, let us find K21 and K22. For that, we have to apply unit displacement in the second coordinate. Our second coordinate is in the point C. So in the point C, we have to apply unit displacement. In the point C, there was a fixed support. But when we apply unit displacement, we can assume that it becomes a hinged support. Let us see how to draw these curves. We are applying unit displacement in the point C. So from the point C, make two clockwise curves. one curve towards the point B and one curve towards the point D, and then see the direction of the arrows and draw these curves. Now let us find K12. For that, from the point B, we have to look other ends, but no need to look at the end A, because for BA there is no curve. Let us look other end C. In the point C, there is a hinged support. If the fair end is hinged, the formula is 2EI upon L. Length of BC is 5. Let us apply that. The moment of inertia for BC is 1.5I. So instead of I, we have to apply 1.5I. For K12, we are getting 0.6 EI. Now let us find K22. For that, from the joint C, we have to look other ends. First, let us look the end B. In the end B, there is a fixed support. So the formula is 4EI upon L. Length of CB is 5. The moment of inertia for CB is 1.5I. Let us apply them. Now let us look other end D. In the end D also there is a fixed support. So we have to apply the same formula, 4EI upon L. Length of CD is 6. The moment of inertia for CD is 3I. Let us apply them. For K22 we have to add these two values. After adding, we are getting 3.2 EI. In the stiffness matrix, we have calculated these four values. Now we are going to find the last row. For that, we have to apply the unit displacement in the third coordinate. Our third coordinate is the survey, which is acting towards the left side. We have kept our third coordinate towards the left side. So towards the left side, we have to apply unit displacement. You can see that I have applied unit displacement towards the left side. Now let us find K31. For that, we have to find the movement in the first coordinate. Our first coordinate is in the point B. So in the point B, we have to find the movement due to sway. The formula to find the moment due to sway is 6EI delta upon L square. Since the sway occurs towards the left side, the moment due to sway will be positive. In this formula, let us apply the values. Delta is 1. Length of column AB is 4 meter. Let us apply that. The moment of inertia for AB is 2I. So instead of I, we have to apply 2I. Finally, for K31, we are getting 0.75 EI. Now let us find K32. For that, we have to find the moment in the point C due to sway. In this formula, let us apply the values. Delta is 1. Length of column CD is 6 meter. Let us apply that. The moment of inertia for CD is 3I. So instead of I, we have to apply 3I. Finally, for K32, we are getting 0.5 EI. The values of K31 and K13 will be same. The values of K32 and K23 also will be same. Now let us find K33. To find K33, we have to add the horizontal reactions in the points B and C. The formula for the horizontal reactions due to sway is 12 EI delta upon L cube. In this formula, let us apply the values. The values of delta is 1. Length of column AB is 4. Let us apply that. The moment of inertia for AB is 2I. So instead of I, we have to apply 2I. Length of the column CD is 6 meter. Let us apply that. The moment of inertia for the column CD is 3I. So instead of I, we have to apply 3I. Finally, for K33, we are getting this. We have kept our third coordinate sway towards the left side. These two reactions also will be acting towards the left side. So K33 will be in the coordinate direction. In this case, this value will be positive. In the stiffness matrix, we have calculated all of the rows. Let us apply them. EI is constant. Let us keep it outside. In this formula, we have calculated everything. Let us apply them. EI inverse is 1 upon EI. For this matrix, we have to find the inverse. We can apply all of the values in the calculator and get the inverse. If you do not know how to find inverse in the calculator, see the description below. There is a link. You can click the link and watch the video. I have used the calculator and got the inverse. Let us add these two matrices. After adding, we are getting this. Then let us multiply these two matrices. After multiplying, we will get theta B, theta C and delta. Now let us make the slope deflection equations and apply these values and get the final moments. Now let us make the slope deflection equations in the column AB. First, let us make for MAB. Since the column AB is subjected to sway, we have to add the sway moment with the equation. Since the sway occurs towards the left side, the sway moment will be positive. In the equation, let us apply the fixed end moment. Length of column AB is 4 meter. Let us apply that. The moment of inertia for the column AB is 2I. So instead of I, we have to apply 2I. In the point A, there is a fixed support. In the fixed support, there will be no slope. So theta A will be 0. After applying the values of theta B and delta, we are getting MAB. In the similar way, we can find MBA. Now let us make the slope deflection equations in the beam BC. In the equations, first let us apply the fixed end moments. Length of BC is 5. Let us apply that. The moment of inertia for BC is 1.5I. So instead of I, we have to apply 1.5I. After applying the values of theta B and theta C, we are getting MBC and MCB. Now let us make the slope deflection equations in the column CD. First, let us make for MCD. Since the column CD is subjected to sway, we have to add the sway moment with the equation. Let us apply the fixed end moment. Length of column CD is 6 meter. Let us apply that. The moment of inertia for the column CD is 3I. So instead of I, we have to apply 3I. In the point D, there is a fixed support. In the fixed support, there will be no slope. So theta D will be 0. After applying the values of theta C and delta, we are getting MCD. In the similar way, we can find MDC. In this analysis, we have calculated all of the moments. For MAB, we got a positive value. That means it is acting in the clockwise direction. For MBA, we got a positive value, so it is also acting in the clockwise direction. For MBC, we got a negative value, that means it is acting in the anti-clockwise direction. For MCB, we got a positive value, that means it is acting in the clockwise direction. For MCD, we got a negative value, that means it is acting in the anti-clockwise direction. Finally, for MDC, we got a positive value, that means it is acting in the clockwise direction. Now we are going to find the reactions. First, let us take the column AB and find the reactions. By taking moment about B, we can find HA. By applying the rule sigma H is equal to 0, we can find HB. Now let us take the beam BC and find the reactions. By taking moment about C, we can find VB. By applying the rule sigma V is equal to 0, we can find VC. Now let us take the column CD and find the reactions. By taking moment about D, we can find HC. By applying this rule, we can find HD. Using the reactions and loads, we can draw the shear force diagram. Using the formulas, we can make the free movement diagram. Using the direction of the movements, we can make the end movement diagram. Then we can combine both of the diagrams and get the bending moment diagram. Now we are going to end this session. Thank you for watching this video.